Welcome back to the AWS VPC creation playlist. So today we will create a custom VPC, which will be very much similar to the default AWS VPC. We have already covered the default VPC flow in the previous video. So if you haven't seen our previous video on AWS default VPC and how traffic flows inside the VPC, I highly recommend watching it. The link is in the description. Okay, so before starting the VPC directly, let's revise the flow inside the VPC, which we have discussed earlier in the previous video. So here, if you see how user request flows inside the VPC is, first of all, user makes request to our VPC. The request comes to the Internet Gateway. Then Internet Gateway forwards this request to the route table, and then route table forward this request to the instances which are available in the subnets. And in between, we have this NACL security layer at subnet level. Also, we have the security group at EC2 instance level. Also, we know what are the subnets. And also, we know what are the CDR blocks. Okay, so I hope this is clear. So today what we will do, we will go ahead and we will create this internet gateway. We will create this route table. We will create this NACL, and we will create these subnets. Then we'll create the security group and then the instances. Okay, so far so good. Alright, then let's go ahead and let's start it. Let's start creating the VPC. Okay, let's search VPC service in search bar. If you see here, in left side panel, you'll able to see this option, named your VPCs. And inside this option, you'll able to see the default VPC, which we have explored in the previous video. So now to create our own VPC, let's click on this button, Create VPC. Then select this option, VPC only here. We are not going to discuss this VPC and more option in this video. We'll discuss this option in the next video. Okay, let's name our VPC. Let's say I'll name it Heisentech Digital VPC. Okay, skip this option as it is, as we are going to use the IPv4 for CDR block only. Then now we need to provide VPC CDR block here. We fully explained what a CDR block is in our networking basics video, how we can calculate the IP address range in between the provided CIDR block. So let's go ahead and provide a CIDR block here by saying we are going to use this CIDR block here. So we'll see, how does this CIDR block suit our needs? And how many IP addresses will we have in this VPC with the given CIDR block? Okay, so what I'll do, I'll just copy this CIDR block somewhere in our notepad. Okay, so now next thing is IPv6 CDR block. So we are not going to use IPv6 CDR block. So select the first option, which is no IPv6 CDR block, and keep other option as it is. And click on the Create VPC button. Okay, so here if you see, you will able to see the VPC which we have created just now, and which has the CIDR block 10.0.0.0/24. That means we can launch certain number of resources in our VPC. Let's see how many resources or EC2 instances we can launch in this particular VPC. Okay, so our VPC CIDR is 10.0.0.0/24. So we already know the formula 2 raised to 32 minus n. In our case, the subnet mask is 24, correct? So 2 raised to 32, 24, which will eventually become 2 raised to 8, which is nothing but 256. So ideally we can say we have 256 IP addresses in this particular VPC CIDR block, and we can launch 256 AWS resources in this particular VPC. So if we need to calculate the range of IP addresses in this VPC, we can simply calculate it as we have already covered this in the networking basics video. So this is my base IP. The next IP will start from the 1, then 2, then 3. And as we know, we have 256 IP addresses in this particular CDR block. So our last IP should be 256. So in this particular VPC, we can create AWC resources ranging from this IP address to this IP address. Okay, I hope this is clear now. Okay, so as we know, VPC is virtualized network that lets you launch AWS resources such as EC2 instances and databases in logically isolated section of the AWS cloud. So let's go ahead and let's launch the AWS resources in our VPC. Those are nothing but Internet Gateway, route table, EC2 instances, subnets, NACL, and security group. So without further delay, let's move forward and start creating each component step by step. So very first we will create Internet Gateway. Let's see how we can create the Internet Gateway. I would say this is the simplest component in the AWS VPC. It only takes about 2 minutes to create an internet gateway. Okay, before we start creating the internet gateway, I'll show you something. So let me select this VPC in the filter, which is Heisentech Digital VPC, which we just created. So if you see, when we create the VPC, the main root table, which is nothing but default root table, we call it main root table. So the main root table or the default root table and the NACL gets created automatically with the VPC creation. Okay, so far so good. So now let's go ahead and let's start creating the internet gateway. So let's click on the Create Internet Gateway button and name it Heisentech Digital IGW. Okay, keep other options as it is. Click on the Create Internet Gateway button. So now we have just created the internet gateway. Okay, so this is our internet gateway, which is Heisentech Digital IGW. So we just created the internet gateway. Now we need to attach this to our VPC, which is nothing but Heisentech Digital VPC. Click on the Attach Internet Gateway button. So we can say, we have just created an internet gateway and we have attached it to our VPC. So far so good. So we are done with this internet gateway creation part. So we have created the internet gateway and we have attached to our VPC. Now let's see, how can we add our internet gateway entry to the root table? For now, we will add it in the main root table or the default root table itself. Okay, so now if you go to the root table, you can see this default route table here. Just click it, and if you see here, we have the by default entry, which is local entry and which has the CIDR block or destination, which is nothing but our VPC CIDR block. Okay, we discussed this in an earlier video in this playlist. So we know root table is a set of routes used to determine where network traffic is directed. So now let's go ahead and let's add our internet gateway route inside our route table. So click on the Edit Routes. Click on Add Route. Select this whole IP address range, which includes almost 4.3 billion IP addresses. We've already discussed what this CIDR block means. Now let's select Internet Gateway here. And if you see here, you will able to see the internet gateway named Heisentech Digital. Internet gateway which we have just created and attached it to our VPC. So I'll go ahead, add this internet gateway in the root table. Click on the Save Changes button. Okay, so we can say we have created the internet gateway. We have attached it to the VPC. Next, we added the internet gateway route entry to the root table, where root table has certain routes used to determine where network traffic is directed inside our VPC. So if you go here and take a look, you'll see under the routes tab, we can see two routes. One is for the local entry and other is for the IGU. So we already discussed this thing. The internet gateway is gateway attached to VPC that allows communication between the VPC and the internet. So when user sends request, it enters to the VPC through the internet gateway, and then internet gateway forwards this traffic to the root table. So we're clear on this flow, right? Let's say when user sends request to the VPC, it enters inside the VPC through the internet gateway. Then this internet gateway forward this traffic to appropriate root table. In our case for now, we are using the main root table. I hope this is clear now. So next thing, this root table forwards our requests to the instances that are available in the subnets. So we have already discussed what are the subnets and what they exactly do. So each subnet in your VPC is associated with the root table, and root table controls how network traffic is directed within and outside the VPC. So let's go ahead and let's create these two subnets. Okay, let's click on the subnet here. So you'll able to see we do not have the subnets for now. And we know what are the subnets. We have already discussed what are the subnets and what is the reason behind creating the. So as we know, AWS VPC is divided into multiple subnets, each belonging to the specific availability zone to achieve the high availability. Okay, and there are two types of subnets, public subnets and private subnets. So in this video, we will discuss what public and private subnets are. Let's move forward and create the subnet. Click on the Create Subnet button. Here, we have to select the VPC. Okay, so we are going to create a subnet inside our VPC, which is Heisentech Digital VPC. Let's select this Heisentech Digital VPC Then let's name our subnet, let's say Digital Hyzentech Public Subnet. I'll name it as a public subnet, okay? So availability zone. So as we know, AWS VPC has multiple subnets inside it, and each subnet is belonging to the specific availability zone. So what we'll do, we'll create the subnet inside the US East 1 ACE. Okay, so now CDR, this is our VPC CDR, and now we need to provide the CDR of our subnet. So let's go ahead and add the CDR here. So I'll say I'll add /28 here. So what we are saying here, we are saying from 256 IP addresses, we are allocating 16 IP addresses to our subnet. Let's take a look at the 16 IP addresses and the range of those IP addresses for this subnet. So let me copy this CDR. Okay, so this is our subnet CDR, right? Now we know our VPC has this many IP addresses, or we can launch 256 AWS resources inside the VPC, and we have allocated 16 IP addresses to our subnet. So if we have to calculate here 2 raised to 32 minus 28, which will become 2 raised to 4, this is nothing but 16. So we can say we can launch 256 AWS resources inside our VPC, and inside that we are dividing those 256 IP addresses into multiple subnets, and inside each subnet we can launch 16 AWS resources. Let's calculate the IP address range, or which 16 IP addresses will be allocated to this particular subnet. So our base IP is 10.0.0.0. So next IP should be 1. Next IP should be 10.0.0.2. And as we know, we have assigned 16 IP addresses to this particular subnet. So the range will go up to 15, as our IP addresses start from 0. So this many IP addresses we are going to allocate to this particular subnet. That means this is the range of our IP addresses. And these IP addresses are being allocated to our subnet 1, which is the public subnet. Okay, so the last IP address of our first subnet is 10.0.0.15. Okay, I hope this is clear now. Alright, so far so good. Next, let's proceed and create the subnet. Okay, so we have created this subnet. And if you look, you'll be able to see the CDR block assigned to this subnet. Also, we know there are only 11 available IP addresses out of the 16 in this subnet, because 5 IP addresses are reserved for the network address, default gateway, broadcast purposes, and DNS server. We have already discussed this thing in the previous video. And the availability zone for this subset is US East 1A. Okay, now let's proceed and create one more subnet, which will be the private subnet. Select the VPC, Hyzentech Digital VPC. Now, let's name it Hyzentech Digital Private Subnet. Okay, so here for the availability zone, we'll create this subnet inside the availability zone, US East 1B. Okay, earlier we have created our subnet in US East 1A. So now here, as we have already created one subnet, which is public subnet, and we are using 16 IP addresses for that subnet out of the 256 IP addresses. Now we need to provide the CDR block, which will use the next 16 IP addresses. So I'll provide the CDR block here, let's say 16/28. So this will allocate the next 16 IP addresses to subnet 2. Let's see how it assigns or allocates the next 16 IP addresses to the second subnet. So this is the CDR block for our subnet, and the first subnet is using IP addresses up to this range. And we are using this CDR block. So our base IP should be 10.0.0.16. And if we look closely, the last IP address of the first subnet is 10.0.0.15. And for the second subnet, we are starting with 10.0.0.16. This means that the CDR blocks or IP addresses within both subnets do not conflict, and this will go up to 32. As we know, this subnet has 16 IP addresses. It will go up to 10.0.0.32. That means our first subnet is using 16 IP addresses, and second subnet is using next 16 IP addresses out of total 256 IP addresses. As we already know, VPC is divided into the multiple subnets. So that is what we are doing here. We are just dividing our VPC into the multiple subnet. So now in our case, out of 256 IP addresses, we are using 16 IP addresses for subnet 1. And for subnet 2, we are using next 16 IP addresses. This is clear, right? Now let's proceed and create this subnet. So let me refresh it So we have created two subnets inside our VPC. So let us go ahead and let us see here. So we have created this internet gateway. As we know, the root table is automatically created when the VPC is created. So we have attached our internet gateway to VPC and added the root for it inside the root table. Then we have created these subnets. I hope this is clear and very easy to understand. So next thing what we will do, we will go ahead and we will launch EC2 instance in our public subnet. Okay, so let's search EC2 to here. Let's click on the instances and let's click on the launch instance button. I'll name it as an Tech Digital Instance 01. Here we are going to use the Amazon Linux only. Next, we'll select the instance type and keep it as is, which is t.micro, since it's part of the free tier. Next, key pair. We have already created the key pair. We will select the existing key pair. And here inside the network setting, just click on the edit network setting. As you can see, we need to select our VPC, which is Tech Digital VPC. And we will launch this EC2 instance in the public subnet within the availability zone US East 1A. Okay, I hope this is clear so far. So now if you see here, the auto-assign public IP is showing disabled. So as we have already seen in the previous video, we can change this setting. Since this is our public subnet, it should automatically assign a public IP address to all the instances we launch within this subnet. So let's go ahead and let's change that setting. Click on the public subnet. Under Actions, click on Edit Subnet Settings. Here, if you see, we will check the auto-assign public IP address checkbox here. Now, the instances we launch within this subnet will automatically be assigned a public IP address. Click on the save. I'll go here and I'll just refresh it. Okay, now if you look here, this option becomes enabled by default. So it will make sure every time when we are launching the instance inside the public subnet, it will assign public IP address automatically to our instance. Next option is about security group. Let's create the security group. So I will name it as an Tech Digital Security Group. Inside the description, I will paste same thing. Here, we will keep the SSH entry as an inbound rule in our security group. We will keep the other options as they are. And let's go ahead and let's launch the EC2 instance. So, we have launched this EC2 instance inside our public subnet, which has the IP address 44.204.179.41. And if you look closely, the subnet for this instance is the Tech Digital Public Subnet. Okay, I hope this is clear and very simple to understand. So now if we have to refer this diagram, so far we have created this internet gateway. We have created this root table, or we are using the main root table, which is default root table, which gets created automatically with the creation of the VPC. Next, we added the internet root entry to the root table. Then we have created these subnets, and inside the public subnet, we have just launched the EC2 instance. Okay, is it clear? So now here, as this user will try to access this instance, which is inside our public subnet. And in between the flow, we have this NACL security layer and security group layer. So NACL works at subnet level and security group works at instance level. So let's see. Have we added the proper entries in the NACL in the security group? So let's go ahead and check the NACL first. So the NACL is created automatically when we create the VPC. If you look closely, inside this NACL, we have allowed entries in both the inbound and outbound rules for all traffic. So that means we have allowed all traffic to the subnets and all the EC2 instances within the subnets through the NACL. Okay, clear? So as we know, NACL provides stateless layer of security and controls inbound and outbound traffic at the subnet level. And when the request enters in the subnet, it is checked against the NACL rules. These are the rule numbers. And in previous video, we have already discussed how these rule numbers works in the NACL and how smaller number gets higher priority in the NACL. In fact, we have seen this by implementing it practically. Okay, so we have all the entries correctly configured inside the NACL. This is default NACL. We can create the custom NACL as well. But for now, we are going to use this default NACL only. Now let's go ahead and check the security group. Okay, so click on the security group. So if you see here, we have this Heisentech digital security group. So if you go inside, here in the inbound rule, we only have the SSH entry. Okay, that means we will be able to SSH into our instance. Let's go ahead and SSH into our instance. Okay, so SSH, and we are using this MyTS key pair. As we know, to securely access EC2 instance, AWS requires the use of a key pair, where public key is stored on the EC2 instance, and we use the private key to connect via SSH. Okay, so here IP address of our instance should be this one. So we are able to SSH to our EC2 instance successfully. So now let's go ahead and let's install Apache on this EC2 instance. Don't worry, I will provide all these commands into the description of this video. You can just copy paste those from the description and you can use it for the Apache installation. So if you see, now that we can run this command, it means we have internet access to our VPC or instance, since we have attached the internet gateway to our VPC. Okay, we have installed Apache on our server successfully. Now let's go ahead and add an index.html file to our var.w.html location. So here what I'm going to do, I'm not going to copy paste the index.html as we have done in the previous video. I have created one project, which is AWS VPC project, and inside that I have created this index.html. Okay, so what we will do, we will just clone this project on our EC2 instance. Okay. Before cloning this, we need to install Git on our EC2 instance. Don't worry, I'll provide this command in the description as well. Okay, so we have successfully installed Git on our EC2 instance. Now let's go ahead and copy this clone URL using HTTP from this repository. You can use this repository as it is, as I have made it publicly accessible. I'll provide the link of this GitLab repository in description of this video. So let's copy this, clone with HTTP URL, and let's clone the project. So if you see, we have cloned this AWS VPC project successfully. I'll go inside this AWS VPC folder. And if you see, we have index.html here inside this AWS VPC project. Now, what I'll do is copy this index.html file to the var.w.html location. Okay, so sudo cp index.html and destination is var.w.html. Okay, so now if you see, we'll be having this index.html inside this var.w.html location. Okay, so far so good. So let's review what we have done so far. We can say we have created this internet gateway, and we have added the internet gateway route to the route table. We have reviewed the NACL. We've seen that we have an SSH entry in our security group. Additionally, we have deployed an index.html file, or in other words, a web page, on our EC2 instance. Okay, I hope this is clear so far. Okay, now let's go ahead and let's try to access our application, which we have deployed on this instance. So we have this public IP address. Let's go ahead and let's hit this public IP address in our browser. So if you see, this is not going to work, since, as you can see in our security group, we don't have an entry for traffic from the user or browser, which originates from outside the VPC. As we already know, security group works at instance level, and once request passes through this NACL to our subnet, it reaches to this security group first, which is attached to our EC2 instance, and security group ensures that only the allowed traffic is forwarded forward to the EC2 instance. Okay, so let's go ahead and let's add one rule in our security group, which will allow traffic from external users to our EC2 instance. Let's go ahead and click on Edit Inbound Rules. Click on Add Rule. And for now, what we'll do, we'll allow all traffic for this EC2 instance. Okay, and click on the Save rule. So if I go ahead and if I reload this page, see, we are successfully able to access our application, which is deployed on our EC2 instance within the public subnet. Okay, I hope this is clear so far. You can use this same Git repository for practice and deploy the same index.html file on your EC2 instance. Here Here's what we have done so far. We have created this internet gateway, then we have created this root table, then we have seen the NACL entries. We have added the required entries in the security group. We have deployed the index.ml file on this EC2 instance. Also, we have created these subnets, and inside the subnet, we have launched the instances. And additionally, our VPC CIDR block includes 256 IP addresses, which means we can launch 256 AWS resources inside our VPC, and we have divided those IP addresses into two subnets. Inside the first subnet, we have 16 IP addresses, and if we consider for the reserved IP addresses, we can say we can launch 11 AWS resources in these subnets. Okay, I hope this is clear to everyone. So now, let's go ahead. And let's take a look at one more thing here. What is public subnet and what is private subnet? As we have only launched the EC2 instance inside the public subnet, and not in the private subnet, right? So we have created only one EC2 instance, or we can say we have launched only one EC2 instance inside this public subnet and not inside the private subnet, right? So if you look at the subnets here, so we have two subnets, and inside the public subnet we have launched one EC2 instance, but we haven't launched any EC2 instance inside the private subnet. So why haven't we launched an EC2 instance inside this private subnet? So as we know, public subnets contains resources that can directly access the internet, right? But inside the private subnet, we can have resources that do not have direct internet access. So we will see in the next video why we do not have internet access for the resources which are launched inside the private subnet. Let's discuss the difference between a private subnet and a public subnet. So let's say this is our public subnet and this is our private subnet. So how can we determine which is the public subnet and which is the private subnet? So inside the root table, we must have a route to the internet through the internet gateway. Okay, and also the instances inside this public subnet typically have a public IP address. Clear? So far so good? Now, regarding private subnets, we can say that there is no route to the internet in the root table, and also the instances in the private subnet do not have a public IP address assigned to the EC2 instance. So, I hope the difference between the public and private subnets is clear. Let's say, for the public subnet, we have the root entry for the internet gateway inside the root table, and also the instances which we are going to launch inside the public subnet have public IP address. About private subnet, there is no route inside the route table for the internet gateway. We'll see in the next video, without adding internet gateway route inside the root table, how we can access the internet. Also, the instances which we launch inside the private subnet do not have the public IP address. So if we see for the public subnet, if we check this instance we have launched in the public subnet and which has the public IP address. So this point is correct. So we have the instance which we have launched inside the public subnet and which has public IP address allocated to that EC2 instance. Now let's verify the first point. So let us go to the root table. If you see inside the root table, we have this internet gateway entry inside our root table, which means we have created the public subnet successfully. So now about private subnet. Let's create one EC2 instance inside the private subnet. Okay, so let's go ahead. And let's create the EC2 instance inside the private subnet. Okay, keep other things as it is. Here we will select existing key pair. Next, inside the network settings, we'll select our VPC. We will select the private subnet. Here, you can see that the auto assign public IP option is disabled. Next, we will use the existing security group. So here we are attaching the security group to our private instance ideally, which is of no use. So we will launch this EC2 instance. So if you see the instance which we have launched inside this private subnet, which has no public IP assigned to it. So this is correct. The instance which we have launched in the private subnet do not have the public IP address. Now let's check the root entry. So this EC2 instance, if you see, we have launched this EC2 instance inside the private subnet. So let's go ahead and check the private subnet. So this is our private subnet. And if you see, under the route table tab, we have assigned this route table to our private subnet, which is Heisentech Digital Private Subnet, which is nothing but our private subnet. And we are using this route table, which is nothing but main root table. So, in our case for now, we are using same root table for both the subnets, for the public subnet as well as the private subnet. So, here, if you look closely, for the private subnet as well, we have the internet gateway entry in the route table. And as we have already claimed that the internet gateway only routes traffic to instances that have a public IP address assigned to them. So now we have two subnets. One is private subnet, one is public subnet. Inside the public subnet, we have EC2 instance. And for that EC2 instance, we have public IP assigned. So that means internet gateway will forward traffic to this public EC2 instance, which has public IP address, which is inside the public subnet. But in here, second EC2 instance case, our internet gateway is not going to forward traffic to this particular EC2 instance because in the very first video we have discussed any device that wants to access the internet must have a public IP address associated with it. Correct? So anyway, even though we have an entry for the internet gateway in the route table, we are still not able to access our private EC2 instance. Okay, so what we will do, we will create two new route tables. One will assign to the public subnet and one will assign to the private subnet. So now create new route table, which will be the custom route table. Okay, named Heisentek Digital Public Route Table. Select our VPC and create the route table. Okay, also we'll create one more route table, which will be Heisentek Private Route Table, and we'll select our VPC and create the route table. So, for the public route table, if you look here, we only have a local entry, which is the default entry. What we will do, we will add one more entry, which is the internet gateway entry. Okay? And save it. And if you see this subnet association tab, we will go here and click on Edit Subnet Associations. So if you see for this public route table or Heisentek public route table, we will associate the subnet, which is nothing but our public subnet. Next, click on Save button. So now if we go to the public subnet, under the round table tab, if you see this is pointing to our public route table, which is Heisentek public route table, which has route to the internet gateway as well as the local route. Okay, so here's what we've done so far. We have created a public route table. We have associated that public route table with the public subnet. And the subnet name is Digital Heisentek Public Subnet. And this public route table has two entries. One is for the internet gateway route, and one is for the local route. And inside this public subnet, we have launched our EC2 instance, which is Heisentek Digital Instance 01. Okay, so what have we achieved so far? We have attached this internet gateway to this route table. And this route table is forwarding our request to the public subnet. Okay, this much is clear, right? Hence, we are able to access our application, which is deployed on our EC2 instance. Sounds good. So now what we will do, as we have created two custom route tables, inside the private route table, if you see we have only one entry, which is a local entry. What we will do is go ahead and add the internet gateway to our private route table as well. Okay, and save the changes. And I will associate this private route table to our private subnet. Okay, so we have attached this route table to our private subnet. So if you see here, inside this Heisentek private route table, we have two entries. One is for the internet gateway and one is for the local entry. And the subnet which we have associated is nothing but the private subnet. So what we are trying to achieve here is this route table forwarding our request to our private subnet. But the instance which we have launched inside the private subnet does not have IP address associated with it. So though we have this internet gateway entry inside our route table, we are still not able to access our EC2 instance which is inside the private subnet. Because if you see, we do not have public IP address to our EC2 instance, and we know the internet gateway only routes traffic to instances that have public IP address assigned to it. So that means this entry is not useful to us, though we have internet gateway entry inside the private subnet's route table. The particular instance which is inside the private subnet do not have access to the internet. So here, what we will do is simply remove this entry. Okay, so now if you see, for the private route table, we do not have any entry for internet gateway. So for the public route table, we have two entries, right? First is for the internet gateway and second is for the local entry, right? So we can say we are able to access the application which is deployed on the public instance. But in case of private route table, we have only local entry. And though we have added the internet gateway inside the private route table, still we will not able to access the internet, as internet gateway only routes traffic to instances that have a public IP address assigned to them. Okay, so now in the next video what we'll do is we'll add NAT gateway inside this route table, and we'll see how the private instances which we have launched in the private subnet can access the internet. So for today, let's just focus on understanding this much part. We have created the public subnet and we have deployed one web page inside our public subnet, and we are accessing this page via this round table as we have entry to the internet gateway for this particular subnet. Okay, so today we have only covered the public subnet part. In the next video, what we'll do is we will cover the private subnet part. So if you ask me, I would say that public and private subnets are just industry terms. Public subnets are used for resources that needs internet access, while private subnets are for secure resources, which are essentially private resources. So today we have created the public subnet. We have launched the EC2 instance inside it. Also, we have accessed the web page which is deployed on the public instance. But in case of private subnet, we have created the EC2 instance under the private subnet. But somehow we were not able to access that private instance, though we have tried adding internet gateway inside the private route table. Okay, so what we have seen today, we have created this internet gateway. We have created custom route tables for our public subnet and private subnet. Also, we have seen the NACL. Also, we have added entries inside the security group. And we have created one public instance inside this public subnet. So today we have only completed this much of the flow. Let's say a user is able to access the applications which is deployed on the public instance which we have launched inside the public subnet. But we haven't covered this flow. So in the next video, what we will do, we will cover this flow where user will able to access the EC2 instance which is deployed inside the private subnet. Okay, for that we need to add NAT gateway entry inside our route table, and we will see how NAT gateway works, also how we can create NAT gateway, and how we can access the instances which are inside the private subnet. Okay, let's quickly revise all the resources we've created today. So today we have created this VPC named Heisentech Digital VPC. Then we have created two subnets, which are public subnet and private subnet. Then we have created these two route tables, which are public route table and private route table. Inside the public route table, we have a route to the internet gateway and a route to the local entry, which is the default entry. Inside the private route table, we have only local entry. In the next video, we will add the NAT gateway entry here to enable internet access inside the private subnet. Also, we have created this internet gateway, and we have attached this internet gateway to our VPC and added entry inside these route tables. Okay. Additionally, we have seen the NACL, and we already know how the rule numbers work within the NACL. We also covered how smaller numbers have higher priority in the NACL, which we implemented in the previous video practically. Then we have created one security group. Inside that security group, we have added two inbound rules. One is for SSH access and the other one is for all traffic. Additionally, we have created these two instances. One is inside the public subnet, which has the public IP address associated with it. And we have deployed this web page on our public instance, and we have accessed it from outside the VPC. Also, we have launched the private instance in the private subnet, which do not have public IP address associated with it. So the task for our next video is we will launch this private instance inside our private subnet. So today we have deployed one web page on this public EC2 instance, or we can say the EC2 instance, which is launched in the public subnet. And we accessed it from outside the VPC from our browser. The second thing we have seen is that we have launched an EC2 instance inside this private subnet, but somehow we were not able to access it. This EC2 instance from outside the VPC, or the user was not able to access this EC2 instance from outside the VPC as we do not have a public IP address assigned to this instance. Also, we do not have internet. Gateway entry inside the route table. So in the next video, we will see how we can access this web page which is deployed on the private instance, and how we can create the NAT gateway and add the NAT gateway entry inside the route table, and how the NAT gateway will help us communicate with the private instance, which are launched under the private subnet. So I hope this is clear to understand and very easy to follow. So that's all for today. In the next video, we will create a VPC again from scratch and launch our resources in public and private subnets, and understand all the security concepts step by step. So don't forget to like, subscribe, and hit bell icon for the updates. Drop any questions in the comments. I'll happy to help. Thanks for the watching. See you in the next video. Thank you.